Hi students, we have already learned some concepts on trigonometric equations and solutions. Now we will try to solve some questions based on those concepts. The first question that says is 1 plus cot theta is equal to cosec theta. I will convert it in terms of cos and sine. That will give me 1 plus cos theta upon sine theta is equal to 1 upon sine theta. I can write it as sine theta plus cos theta is equal to 1. Now divide it by root 2 both sides. So that shall give me cos theta into 1 by root 2 plus sine theta into 1 by root 2 is equal to 1 by root 2. Now this is of the left hand side is of the form of cos theta, cos A cos B plus sin A sin B. That can be written as cos of theta minus pi by 4 is equal to cos of pi by 4, because that is cos A plus cos A cos B plus sin A sin B, that is cos A minus B. Now theta minus pi by 4 is equal to 2n pi plus minus pi by 4, or theta is equal to 2n pi plus minus pi by 4 plus pi by 4. I'll be having two values based on plus and minus, either it will be 2n pi or 2n pi plus pi by 2. And C is my correct option for this question. Coming to the next question. The next question says if tan theta plus cot theta is equal to 2 cosec theta, then the general value of theta is. Now I'll do again the same approach. I'll proceed. I'm just converting the trigonometric ratios in terms of sine and cos. That gives me sine square theta plus cos square theta upon sine theta cos theta is equal to 2 over sine theta. Now the numerator on the left hand side is an identity itself, that will be equal to 1. I'll be left with sine theta in the denominator, so that will give me cos theta directly being equal to 1 by 2, which instead is equal to cos of pi by 3, and I would get cos theta is equal to cos pi by 3. That will give me theta is equal to 2n pi plus minus pi by 3. That will be option C. Coming to the next question. The next question says cos 2 theta is equal to root 2 plus 1 cos theta minus 1 by root 2. Now cos 2 theta can be written as 2 cos square theta minus 1 being equal to root 2 plus 1 cos theta minus 1 minus 1 by root 2. Minus 1 on both sides would cancel out. I would transpose all the terms on one side to get a quadratic equation in terms of cos. That will be 2 cos square theta minus root 2 plus 1 cos theta plus 1 by root 2 is equal to 0. Finding cos theta from here would be easy. That will be minus b plus minus root over b square minus 4 a into c whole over 2a. That shall give me root 2 plus 1 plus minus root over. Now this whole term would come out to be root 2 minus 1 whole square. The root and square would cancel out, giving me root 2 plus 1 plus minus root 2 minus 1 whole over 4. Cos theta is equal to root 2 plus 1 plus minus root 2 minus 1 whole over 4. I will have two values of theta then, cos theta then. One would be, and I am considering as positive, and the another one when the negative sign is considered. That shall give me either 1 by root 2 or 1 by 2. Both of them can be written as either cos pi by 4 or cos pi by 3. Hence theta would be either 2n pi plus minus pi by 4 or 2n pi plus minus pi by 3. I will look at the options that I have out of it. Hence option B is correct for this question. Let's proceed to the next question. The next question is sin 6 theta plus sin 4 theta plus sin 2 theta is equal to 0, and I have to solve for theta. I'll combine sin 6 theta with sin 2 theta first. Using sin c plus sin d would giving me 2 sin c plus d by 2, that is 6 plus 2 is 8, so 4 theta, and cos c minus d by 2, that is 6 minus 2 is 4, so 2 theta, plus sin 4 theta is equal to 0. I would have, now I'll take sin 4 theta common out of the equation, that shall give me 2 cos 2 theta plus 1 is equal to 0. So either the first term is 0 or the bracket term is 0, that is either sin 4 theta equal to 0 or 2 cos 2 theta plus 1 is equal to 0. Now 4 theta would be either equal to n pi or cos 2 theta being equal to minus 1 by 2. Cos 2 theta can be minus 1 by 2 can instead be written as cos of 2 pi by 3 is equal to cos 2 theta, and hence 2 theta would be 2n pi plus minus 2 pi over 3, and on the other equation would give me theta as n pi by 4. This equation when considered would give me n pi plus minus pi by 3. So either this or this solution. So these are the two solutions in OR, and hence the option that is correct for this is A. That's the right option. Coming to the next question. The general solution of tan 5 theta is equal to cot 2 theta is, tan 5 theta is equal to, now I can write cot as pi by 2 minus theta, that would be, this would turn out to be tan then, when I change the argument and do the calculation. So now this is of the form of tan theta is equal to tan alpha, and I would get 5 theta is equal to n pi plus alpha plus pi by 2 minus 2 theta. That will be theta is equal to n pi by 5. I'll have to first transpose and get 7 theta is equal to n pi plus pi by 2, or theta being equal to n pi by 7 plus pi by 40. So that's the value of theta satisfying this equation, the general value of theta. That's option A. Proceeding to the next question. The next question says 4 sin 4 theta 4x plus cos 4x is equal to 1. 4 sin 4x plus cos 4x is equal to 1. I'll transpose cos on the other side. 1 minus cos 4x. I'll factorize it. Factorizing it would give me 1 plus cos square x and 1 minus cos square x. This in itself is sin square theta, so that becomes sin square x or 1 plus cos square x. I would transpose the terms on one side. That shall give me sin 4x minus sin square x into 1 plus cos square x is equal to 0. This might be coming out to be a quadratic equation in terms of sign. Then I'll take sin square common, which would give me 4 sin square x minus 1 plus cos square again can be written as 1 minus sin square x is equal to 0. Or so two major brackets are formed. One is this big bracket, the other one is sin square term. I would solve for this bracket and then segregate them. So sin square x into 4 sin square x minus 1 minus 1 plus sin square x is equal to 0. which instead would be giving me sine square x into 5 sine square x minus 2 is equal to 0. So either the first term is 0 or this bracket term is 0. I would solve for it. The equation was sine square x into 5 sine square x minus 2 being equal to 0. So either sine square x is equal to 0 or sine square x is equal to 2 over 5. That is sine x is equal to root 2 over 5 or sine x is equal to 0. This equation shall give me x is equal to n pi, and here I would get x is equal to sine inverse root 2 over 5. Now this is the principal solution, not the general solution. This is just the value of theta. So for finding the general solution in this case, I would have to then use n pi plus minus 1 raised to n, the value of theta being sine inverse root 2 over 5. So that's the general solution. Now I'll check for the options. So A is the correct option that I have, because this one does not involve, my option does not involve plus minus, but a minus 1 raised to n. Coming to the next question. The next question is the most general value of theta satisfying tan theta is equal to minus 1 and cos theta is equal to 1 by root 2. Now tan theta is negative and cos theta is positive. This is possible only in fourth quadrant. So my theta would definitely be lying in fourth quadrant itself. I would plot the value of theta in this quadrant in such a manner that I get tan theta is equal to tan alpha. That shall be tan of minus pi by 4 and cos theta is equal to cos of minus pi by 4. Now I can again do the same for that. I can add 2 pi to it, to the theta value. That shall give me tan of 2 pi minus pi by 4 and cos theta being equal to cos of 2 pi minus pi by 4. The resultant solution that I would be getting would be tan theta equal to tan of 7 pi by 4 and cos theta is equal to cos of 7 pi by 4. Now these three equations have to be solved simultaneously. Hence the general solution for that would be theta is equal to 2n pi plus alpha, that is 7 pi by 4, and hence my answer for this question is C. Moving on to the next question. The next question is the most general value of theta satisfying both the equations sin theta is equal to minus 1 and tan theta is equal to plus 1 by root 3. Sin theta being negative and tan theta is positive, so my theta value should lie in the third quadrant. And the third quadrant, if I try to plot sin theta is equal to minus 1 by 2, that shall be minus of sin pi by 6 is equal to sine of pi plus pi by 6 would be 7 pi by 6, whereas for tan theta is equal to 1 by root 3, it is already equal to tan pi by 6 in the first quadrant, but I have to plot it in third quadrant, so that will be 7 pi by 6. Hence my theta value is given. Now I have found my theta value. This is the alpha value. Hence the general value of theta would be 2n pi plus 7 pi by 6. Now the options that are given to me, none of the options are containing the alpha value as 7 pi by 6. Also, none of the options are of the form that of the solution that I have achieved. So D is the most probable option in this question. So the next question says 5 cos 2 theta plus 2 cos square theta by 2 plus 1 is equal to 0, and theta lying between minus pi and pi, and then I have to find the value of theta. So it's not a general solution, I'll just have to find the value of theta. What I would do is, first I would write cos 2 theta in terms of cos theta, that is 2 cos square theta by 2, 2 cos square theta minus 1 plus, now 2 cos square theta by 2 can be written as 1 plus cos theta plus 1 is equal to 0. That would give me a quadratic equation in terms of cos theta. So 10 cos square theta plus cos theta minus 3 is equal to 0. If I solve this by quadratic formula, I would get cos theta is equal to minus 1 plus minus root over b square minus 4a into c whole over 2a. So cos theta is giving me the value minus 1 plus minus. Now if you notice the root, that would give you 121, that's a root of 11, that is square of 11. So that becomes minus 1 plus minus 11 by 20, and I would get two values of cos theta, which would be minus 1 plus 11 by 20, and another one would be minus 1 minus 11 by 20. So correspondingly I would get values. This would give me half, and this one would give me minus 3 by 5. So solving for the value of theta, theta would be, I have two values of cos theta, so theta would be either pi by 3 or cos inverse of minus 3 by 5. Now cos inverse of minus 3 by 5 can be written as, cos is negative in second quadrant, so I would write pi minus cos inverse 3 by 5, because in that quadrant itself I try to find the principal solution, and this gives me the value. The option to be correct is D. Moving on to the next question now. The next question is a paragraph type question in which the information is given and I have to find the linked answer questions. So three questions are linked to this, 11th, 12th and 13th. The information given is sin x cos 2y is equal to a square minus 1 whole square plus 1, and cos x sin 2y is equal to a plus 1. I have to find the number of values of a for which the system has a solution. So that means the system is consistent. Now if you look at the information that is given, two trigonometric ratios are multiplied. Sin x lies between minus 1 and 1, and cos x again lies between minus 1 and 1. On the right side, if I see, it's a square term with an addition to it, so I need not compare it with a negative quantity. I shall just have one-sided inequality, that is a square minus 1 whole square plus 1 is less than or equal to 1. That would give me a square minus 1 whole square is equal to 0, less than or equal to. Now to find the value of a, I would consider the equal sign, and I would get a square minus 1 is equal to 0, or a is equal to plus minus 1. Now from this equation I am getting two values of a. On the other equation, the other information that is given to me is sin 2y into cos x is equal to a plus 1. I would apply the same procedure here, that is the two trigonometric coefficients are multiplied, which are lying between minus 1 and 1. Hence my a plus 1 would also lie between minus 1 and 1. Now I would put in these values, substitute the values into this, check for the inequality. Now by checking into this inequality, I would get that if I have plus 1, this would not lie in the range of minus 1 and 1, whereas if I put minus 1, I would get a 0 which lies between minus 1 and 1. Hence a is equal to minus 1. So only for one value of a, that is minus 1, I shall have a consistent system. Hence option A. Now coming to question number 12. Question number 12 says the number of values of x belonging to 0, 2 pi when the system has a solution for permissible values of a, and for the next question, the number of values of y when the system has a solution for permissible values of a. So I'll solve them together. For solving, what we do is, I would continue with the information that was given to me, that is sin x cos 2y was equal to a square minus 1 whole square plus 1, and cos x sin 2y was given to me as a plus 1. I would put in the value of a that I derived from the earlier question, that was a equal to minus 1. So I would get this as 1 and this as 0. If I add the two equations, that is sin x cos 2y is equal to 1, this being the first equation, and cos x sin 2y is equal to 0, this being the second equation. If I add the first and second equation, I would get sin of x plus 2y is equal to 1, and if I subtract the two equations, I would get sin of x minus 2y is equal to 1 again, because sin x cos 2y plus cos x sin 2y is equal to 1. Now on the left hand side, if I see sin x cos 2y plus cos x sin 2y is in itself sin x plus 2y, hence I get this equation, and reversely when subtracting the two equations, that is sin x cos 2y minus cos x sin 2y would be sin of x minus 2y. Now if I compare and find the solution of these two equations simultaneously, so for x plus 2y I would get 2n pi plus pi by 2, and for this equation, second equation, I would get x minus 2y is equal to 2n pi minus pi by plus pi by 2 again. Now I would change the variable, that would be 2m pi. So these are the two equations that I get. Let them be equation 3 and 4. So now with the equation 3 and 4 written here again, x plus 2y is equal to 2n pi plus pi by 2, and x minus 2y being 2n pi plus pi by 2. If I add the two equations, I will get the value of 2x being n plus m plus pi, which would give me the value of x as m plus n pi plus pi by 2. Now the value of x has to lie between 0 and 2 pi. Also, if I check for the value of y now, I subtract these two equations, so I would get 4y is equal to, and hence y would be pi by 2 n minus m. Y also has to lie between 0 and 2 pi, and m and n both belong to integers. So this has to be a complete integer, and this one also has to be a complete integer because of the closure property of integers. So from this you would get two values of x, and for y you would get 5 values, and hence I would derive and mark the answers as the value of x has to be this, and the value of y as option D. The next question says sin 4 theta minus sin 2 theta is equal to 2. So sec 4 theta minus sec 2 theta is equal to 2. I would convert it in cos form. I would get cos 2 theta minus cos 4 theta is equal to 2 cos 4 theta cos 2 theta. I would transpose all the terms on one side, that is cos 2 theta minus cos 4 theta minus twice of cos 4 theta cos 2 theta is equal to 0. That would give me, now I would expand this to get cos 2 theta minus cos 4 theta minus cos c plus d by 2 cos c plus d, that will be 6 theta plus cos of 2 theta is equal to 0. cos 2 theta would cancel out, giving me cos 4 theta plus cos 6 theta is equal to 0. I would apply the C and D formula. 2 cos c plus d by 2, that is 4 plus 6 by 2, is 5 theta, and cos of 6 minus 4, that is 2 by 2 theta, is equal to 0. So either cos 5 theta is equal to 0 or cos theta is equal to 0. So that would give me 2n plus 1 pi by 2. Now if I check for these values, for both of them, I would get either theta is equal to 2n plus 1 pi by 10, or as it is, that is 2n plus 1 pi by 2, which if expanded would give me pi by 5 plus pi by n pi by 5 plus pi by 10, or two n plus 1 pi by 2. So the option for this would be option C. Now the next question says sec x cos 5x plus 1 is equal to 0 and x lies between 0 and 2 pi. So sec x into cos 5x plus 1 is equal to 0. I would convert this into cos x. That would give me cos of 5x upon cos x plus 1 is equal to 0, or cos 5x plus cos x is equal to 0. That would give me 2 cos 5 plus 1, that is 6 by 3, 2 is 3x, into cos of 5 minus 1 is 4 by 2, that is 2x is equal to 0. So either cos 3x is equal to 0 or cos 2x is equal to 0, and I would directly be equating them to pi by 2. So I would get x as either pi by 6 or pi by 4. And for this question, my answer would be C. Let's start with the next question. The question is 2 cos square x by 2 sin square x is equal to x square plus 1 by x square, and x lies less than pi by 9, less than or equal to pi by 9, has no solution, one solution, more than one real solution, and cannot be said are the options. So if I look at the left hand side carefully, the left hand side is twice of a value lying between 0 and 1 and another value lying between 0 and 1. Why did I take out them to be 0 and 1? Because cos x lies between cos x and sin x. For any value of theta lie between minus 1 and plus 1. So their square would have to be lying between. I cannot compare, it cannot be equal to negative, so square is being compared with just the positive domain. Okay, so it is lying between, the whole value would be lying between 0 and 2. So LHS is less than or equal to 2. If I consider the RHS, I would get x square plus 1 by x square. It can be written as x minus 1 by x whole square plus 2. It's a square, that's positive, plus 2 is again positive, so that makes up for the positive number greater than 2. So RHS, I derive that it is greater than, it will be greater than 2. So this is the first equation, that's second equation. Comparing first and second, I get no solution. I'm not able to get both the values to be equal for any value of x, hence I would get no solution. Moving on to the next question. The next question says solution of sin x plus cos x is equal to 1. That's a very easy one. We have already covered this in the intermediate steps of previous questions. Just divide it by root 2 both sides to get sin x into 1 by root 2 plus cos x into 1 by root 2 is equal to 1 by root 2. Now it can be condensed into either sin of x plus pi by 4 or cos of x minus pi by 4, and accordingly I would get sin pi by 4 or cos pi by 4 both being equal to 1 by root 2. So I can derive two equations out of it, that is sin of x plus pi by 4 is equal to sin pi by 4 or cos of x minus pi by 4 is equal to cos pi by 4. That shall give me x plus pi by 4 being equal to n pi plus minus 1 raised to n pi by 4 or x minus pi by 4 being equal to 2n pi plus minus pi by 4. Solving the first one, I get x is equal to n pi plus of minus 1 raised to n pi by 4 minus pi by 4 or x is equal to 2n pi plus minus pi by 4 plus pi by 4. So these are the two independent solutions. Both of them are true. I would have to check out from the options which one is matching with the options. So 2n pi ruled out. If I look at this, this looks similar to what I have derived from the cos term, but see, it does not have, it is not considered all the solutions, which would include the negative sign also. Considering the negative sign, that will be just 2n pi. So I have already ruled this out. So this would be ruled out on the same reason. If I consider the third option that matches with the sin theta is equal to sin alpha form, that is this solution, and it matches with my answer. Moving on to the next question then. General solution of sin x minus 3 sin 2x plus sin 3x is equal to cos x minus 3 cos 2x plus cos 3x is its general solution that I have to find. I'll condense these two together and cos 3x together. So on the left hand side I get 2 sin 2x cos x minus 3 sin 2x is equal to 2 cos 2x cos x minus 3 cos 2x. Transposing all the terms on one side, I get 2 sin 2x cos x minus 2 cos 2x cos x minus 3 sin 2x plus 3 cos 2x is equal to 0. Taking common from the first two terms, 2 cos x is common, leaves me with sin 2x minus cos 2x. Minus 3 common out of the last two terms, I get sin 2x minus cos 2x is equal to 0. Then the bracket term is being taken common in the next step, and I am left with 2 cos x minus 3 is equal to 0 as another term. So I'll check for both the terms, that is sin 2x minus cos 2x is equal to 0 or 2 cos x minus 3 is equal to 0. That gives me cos x is equal to 3 by 2, not possible. Whereas if I solve this, I get tan 2x is equal to 1 or 2x is equal to n pi plus pi by 4 for the value of x. That becomes n pi by 2 plus pi by 8. That's my solution. That matches with option B. Moving on to the next question. So the question is cos p minus 1 x square plus cos px plus sin p is equal to 0 in the variable x has real roots. This is a quadratic equation in terms of x square x and constant term. In the variable x has real roots. Quadratic equation having real roots, that means discriminant is greater than or equal to 0. So I have to find the interval in which the p can take values. So d is b square minus 4ac, that is cos square p minus 4 sin p into cos p minus 1 is greater than or equal to 0. I would get cos square p minus 4 sin p cos p plus 4 sin p greater than or equal to 0. I would form a whole square out of this being a square and this being 2ab. I would have to add 4 sin square p and subtract 4 sin square p on the same side to get cos p minus 2 sin p whole square. Now the first term is included, the 2ab term included, square term included. I am left with 4 sin p minus 4 sin square p plus 4 sin p minus 4 sin square p greater than or equal to 0. This is already a positive term. Let's condense this to get 4 sin p 1 minus sin p. This is already greater than 0. If this has to be greater than 0, for that sin p has to be positive, and for sin p is being positive, if I consider the unit circle, it is positive only in first and second quadrant, that is 0 to pi. My option would be, so for d to be greater than or equal to 0 such that p belongs to 0 comma pi. Next question is cos square theta plus sin theta plus 1 is equal to 0. Mind it, it's not sin square theta, it's just sin theta. So I'll rewrite cos square theta as 1 minus sin square theta plus 1 plus sin theta is equal to 0. Now it is of the form of a square minus b square. Let's write it as a plus b and a minus b plus 1 plus sin theta is equal to 0. That gives me, I'll take 1 plus sin theta common and left with 1 minus sin theta plus 1 is equal to 0, or 1 plus sin theta into 2 minus sin theta is equal to 0. That gives me sin theta as minus 1 or as 2. So 2 can be ruled out as sin theta lies only between minus 1 and 1. The only viable option is sin theta is equal to minus 1. Solving for it, I get theta is equal to 3 pi by 2. Now 3 pi by 2 lies in, let's see in which interval should it lie. This is minus pi by 4 comma 7 pi by 4, that's 5 pi by 4, that's 3 pi by 4 and pi by 4. So 3 pi by 2 lies here, and if I check minus pi by 4 to pi by 4, that's quadrant 1, that's one interval. Then pi by 4 to 3 pi by 4, second interval, no, and then third is 3 pi by 4 to 5 pi by 4. Hence option D, that is 5 pi by 4 to 7 pi by 4 is the correct option. Next question is the number of solutions of the equation 2 cos e raised to x is equal to 5 raised to x plus 5 raised to minus x. Are no solutions, one solution, two solution, infinitely many solutions. Now let's see, let's first check for what values of x can they be equal to. So this is an even function. For any values of x, it will, or minus x, it won't change. So also the minimum value I can feed in, because this has to lie between 0 and has to lie between minus 2 and 2, and this has to be, so this can never be negative, so I will rule out. So it will be lying between 0 and 2. The left hand side would also be lying between the same range. Then if I see the minimum value it can have is for value 0, x is 0, then it will be 2, and if I put x is equal to 0 on the left hand side, that will not be equal to 2, that will be cos of 1 radian. So these two sides won't match, they're not matching for any value of x, hence I get no solution. As LHS not equal to RHS for any value of x. Moving on to the next question. So let's start with the next question. The next question says 2 sin square x plus 3 sin x minus 2 is greater than 0 and x square minus x minus 2 less than 0. X is measured in radians. Then x lies in the interval pi by 6, 5 pi by 6, minus 1 pi, 5 pi by 5, minus 1 2 and pi by 6 comma 2. So let's find the value of x and then find out in which intervals the common value of x should lie to satisfy both the equations. Starting with the first equation, that is 2 sin square x plus 3 sin x minus 2 greater than 0. Factorizing it, 2 sin square x plus 4 sin x minus sin x minus 2 is greater than 0. I'll get 2 sin x as and sin x plus 2 . The two factors would be 2 sin x minus 1 and sin x plus 2 greater than 0. That's not possible, as sin x would be lying outside the value, in the outside the range for which it is defined, that is sin x has a range of minus 1 and 1. So it will be out of the range of minus 2. So I will solve for sin x is equal to sin x greater than 1 by 2, that is x would be have to be greater than 5 by 6. So that's the first range that I get. Solving for the second equation, that is x square minus x minus 2, that shall give me this is less than 0. So again I will factorize it and I will get x into x minus 2 plus 1 into x minus 2 less than 0. So x plus 1, x minus 2 less than 0. So two cases are possible, or x plus 1 greater than 0, x minus 2 less than 0. That will give me x minus less than minus 1 and x greater than 2, or x greater than minus 1, x less than 2. Of these two values I get, if I plot them on the number line, that's minus 1, 0 and 2. So x is less than minus 1 and x is greater than 2, so no common solution. If I plot this on the number line, I get 0, minus 1 and 2, x is greater than minus 1 and x is greater than 2. So this is the common range, that is x greater than 2, x less than 2. I will get x less than 2, and the first range was x greater than pi by 3, pi by 6. So x shall lie in the range of pi by 6 and 2, and the option would be option D. Moving on to the next question. The general value of theta satisfying the equation tan square theta plus sec 2 theta is equal to 1 is, I have to find the general solution. I can write tan square theta in terms of cos 2 theta, that will be 1 minus cos square of 2 theta upon 1 minus cos 2 theta upon 1 plus cos 2 theta, plus sec 2 theta can be written as 1 by cos 2 theta is equal to 1. Solving it further, we will get cos 2 theta minus cos square of 2 theta plus 1 plus cos 2 theta is equal to cos square 2 theta plus cos 2 theta. Cos 2 theta would cancel out and I would get 2 cos square theta minus cos 2 theta minus 1 is equal to 0. It's a quadratic equation again. Factorizing it, 2 cos square 2 theta minus 2 cos 2 theta plus cos 2 theta minus 1 is equal to 0. 2 cos 2 theta taken common, I get cos 2 theta minus 2 minus 1, and cos 2 theta minus 1 is equal to 0. So the two factors are 2 cos 2 theta plus 1 and cos 2 theta minus 1 is equal to 0. So the two values of cos 2 theta that I obtain are minus 1 by 2 and plus 1. So corresponding values of 2 theta that I get are 2n pi plus minus 2 pi by 3 and 2n pi plus minus, that's for it's 0, so that will be just 2n pi. And finally the value of theta that I would get is n pi plus minus pi by 3 and n pi. So that matches with the first option. That does not have a minus, so it matches with the second option, option B. That's my answer. That is n pi and n pi plus minus pi by 3. Moving on to the next question. The number of values of x in the interval 0, 5 pi satisfying the equation 3 sin square x minus 7 sin x plus 2 is equal to 0. So it's again a quadratic equation. Solving it for the value of x, sin x, I can split it in terms of, I can do the middle term splitting. That is 3 sin square x minus 6 sin x minus sin x plus 2 is equal to 0. I get 3 sin x as a common, giving me sin x minus 2 minus 1 of sin x minus 2 equal to 0. So the factors are 3 sin x minus 1 and sin x minus 2 equal to 0. So sin x can take values from all of 1 by 3 and 2. So 2 can be neglected. The value of sin x that I get, which will satisfy this equation, is 1 by 3. Now it is a positive value, so it shall and lies between 0 and 1. So it shall lie the x shall lie between 0 and pi by 2. Then it can lie from pi by 2 to pi, as this is the second quadrant. So this is the first quadrant, this is the second quadrant. In both of them, sign is positive. So if I plot this on the unit circle for the value for the interval 0 to 5 pi, that is first circle, second circle, and then second circle, and then half a circle more. So I will traverse through the two quadrants, that is one value is in this quadrant and another value would lie in this quadrant. So in the first circle I would get 2 values, then in the second circle again I would get 2 values, in the third circle, half circle, again I would get 2 values. So it will have total of 6 solutions. That is option C. Next question is maximum value of cos alpha 1 into cos alpha 2 up till cos alpha n under the restriction alpha 1, alpha 2, alpha n all lying between 0 and pi by 2, and cot alpha 1 into up till cot alpha n is equal to 1. So I get, if I have a look at the second condition that I have, cot alpha 1 up till cot alpha n is equal to 1. So I would get cos alpha 1 into cos alpha 2 up till cos alpha n being equal to sin alpha 1 sin alpha 2 up till sin alpha n. Now you must be wondering if I could directly find the maximum value of this expression by having them as 0, all the values to be 0, they can be equal to 0, but if alpha 1 alpha 2 all the alphas are 0, then this won't be possible. Hence I have to find a maximum value considering these two conditions to be true. That's why I am doing this, multiplying both sides with cos alpha 1 cos alpha 2 up till cos alpha n. So I get cos alpha 1 cos alpha 2 up till cos alpha n whole square is equal to sin alpha 1 cos alpha 1 till sin alpha n cos of alpha n. Then this expression would be cos alpha 1 up till cos alpha n whole square. Multiplying and dividing this second term that I got with 2 raised to n, so that will be 2 in each bracket n times and 1 by 2 raised to n here, so that gives me 1 by 2 raised to n sin 2 alpha 1 up till sin of 2 alpha n. Now the maximum value, suppose if alpha 1 was and alpha 1 and alpha 1 to alpha n were ranging from 0 to pi by 2, and now so 2 alpha 1 2 alpha 2 would be ranging from 0 to pi, and in that interval the maximum value sine can attain is 1. Hence cos alpha 1 up till cos alpha n would be equal to 1 by 2 raised to n by 2. That will be option A. Now the next question that I have is the number of integral values of k for which the equation 7 cos x plus 5 sin x is equal to 2k plus 1. I know that a minus of a root over a square plus b square is less than a cos b plus a cos alpha plus b sin alpha is less than, again that is again less than a square plus b square root. So if I calculate this, I would get root of 74 from this expression. I get root over 7 square plus 5 square, that is root 74. It is 7 cos x plus 5 sin x less than root 74. As it is a less than sign, so and I shall have a perfect square as this expression is equal to 2k plus 1 and k is an integer. K here should be an integer, so these should also have an integral value to be compared with. So the square root that is most closest to it is that square that is most closest to it is less than that is 64, which is a square of 8, and correspondingly on the other end that is minus 8. So if I calculate for the value of k in this, I would have to subtract 1 on each side, that would give me minus 9, less than 2k, less than 7, or k lying between 7 by 2 and minus 9 by 2, that will be minus 4.5 and 3.5. So the integral values of k would be 4, minus 4, minus 3, minus 2, minus 1, 0, 1, 2 and 3. That will be 1, 2, 3, 4, 5, 6, 7 and 8. So 8 values are possible. Now for the next question, cos alpha minus beta is equal to 1 and cos alpha plus beta is equal to 1 by e, where alpha beta belong to minus pi to pi. Number of pairs of alpha beta which satisfy both the equations is, starting with the first equation, cos alpha minus beta is equal to 1, that gives me alpha minus beta being equal to 0. I have alpha is equal to beta. Now for the second equation, I have cos alpha plus beta is equal to 1 by e. Substituting this in the second equation, I get cos 2 alpha is equal to 1 by e. It's a cos, so it should be lying between 0 and 1. Also this is lying between 0 and 1. So 1 by e already lies between 0 and 1, and I have for the value of this alpha lying between 0 and minus pi and pi, 2 alpha shall lie between minus 2 pi and 2 pi, closed intervals. So now if I check for these values, that is cos lying between 0 and 1, that is cos has to be positive. Now cos is positive in the first circle, that is from 0 to pi 2 pi, it is positive in the first quadrant, and then in the fourth quadrant, that is just in one circle. So for one circle, cos positive in first and fourth. So if I have to calculate for the value of 2 alpha lying between 0 or minus 2 pi and 2 pi, so that would include 0 to 2 pi and minus 2 pi to 0, closed intervals. So it would have two values, and this would again have two values. That makes it total 4 solutions of alpha, and correspondingly 4 solutions of beta. That gives me 4 solution sets of alpha comma beta satisfying equations. So 4 solution sets are possible. That is option D. So the next question that we have is the values of theta belonging to 0, 2 pi for which 2 sine square theta minus 5 sine theta plus 2 is greater than 0 are. Then some intervals are given to us as options. The equation is a quadratic equation. We will factorize it. Plus 2 is greater than 0. That can be factorized as 2 sine square theta minus 4 sine theta minus sine theta plus 2 greater than 0. That gives me 2 sine theta is common, and I get sine theta minus 2, 0, that being minus 1. So the two factors are 2 sine theta minus 1 and sine theta minus 2 greater than 0. So either both are positive or both are negative. That is 2 sine theta minus 1 greater than 0 and sine theta minus 2 is greater than 0, or 2 sine theta minus 1 is less than 0 and sine theta minus 2 again less than 0. Both of them are garbage values. I'll solve for these two values only. I would get first I would get sine theta is greater than 1 by 2, but theta would be greater than pi by 6 and 5 pi by 6, as sine is positive only in the first and second quadrant. Among these, the common value that I would get is theta greater than 5 pi by 6. Solving this equation, I get sine theta to be less than 1 by 2. That gives me theta less than pi by 6 and 5 pi by 6 again, but this time the common range would be theta less than pi by 6. And the initial and the final value of the range among the range that I have is the theta lying between 0 and 2 pi. So the solution had to be such that 0 to pi by 6 exists, and then 5 pi by 6 to 2 pi. That is option A. Next question. Two equations are given to us. We have to find the number of solutions for the pair of equations. The first equation is 2 sine square theta minus cos 2 theta is equal to 0. I will have 2 sine square theta and cos 2 theta written in terms of sine square theta, that is 1 minus 2 sine square theta. That gives me minus 1 plus 2 sine square theta is equal to 0. I will have 4 sine square theta minus 1 is equal to 0. So that gives me 2 sine theta plus 1 and 2 sine theta minus 1 as factors. So the values of sin theta that are achievable are minus 1 by 2 and plus 1 by 2. For the next equation, I have 2 cos square theta minus 3 sin theta is equal to 0. Converting sin cos square theta in terms of sin square theta, that is 2 minus 2 sin square theta minus 3 sin theta is equal to 0. That gives me 2 sin square theta plus 3 sin theta minus 2 is equal to 0. That's a quadratic equation. Solve it further. 4 sin theta minus sin theta minus 2 is equal to 0. Then the factors would be, I would take 2 sin theta common. I would have sin theta plus 2 and minus 1, then same factor here. So the factors would be 2 sin theta minus 1 and sin theta plus 2 is equal to 0. That would be a garbage, as sin theta cannot be compared with minus 2 or 2. I'll have the value of sin theta here as 1 by 2, which would be matching with this, the first equation, and the common equation that I'll have is sin theta is equal to 1 by 2, which in the first circle is possible in the first and second quadrant. So it will have two values, that is option C. Coming to the next question, tan theta is equal to minus 1 by root 3, sin theta 1 by 2 and cos theta minus 1 by root 3 by 2. So tan is positive, tan is negative here, sin is positive and cos is negative. That's only possible in second quadrant. So my theta has to lie in second quadrant. Tan theta in second quadrant can be expressed in this form as tan of pi minus pi by 6. Sin theta can be expressed as sin of pi minus pi by 6, and cos again would have to be negative and then would be expressed as pi minus pi by 6. So the values would be tan 5 pi by 6, sin 5 pi by 6 and cos 5 pi by 6. I'm asked about the principal value, that is 5 pi by 6. Option B is the correct answer. With this we end the video solutions. Hope you liked listening to the video. If you have any more doubts, queries or any questions, you can post it on the online discussion forum. Thanks for watching.